Welcome to this next episode of Math Method and creating a Super Mario game. In this episode, we're gonna look at animations. So basically, when I say animations in this context, I mean we're gonna make Mario run here so that he takes some steps. And we also have these chance blocks over here with question marks on them, and they're supposed to blink. So we look at this little emulator here. Alert. See that Mario is running, and these blocks are indeed, they're flashing. Oink, oink. So let's look how we can do that now. So back here into the editor, and we are going to first clean up a thing here in the entities file because we're gonna work in it. And the thing I want to clean away is this velocity reference here, because we are never gonna use that again. I think actually we can remove the whole file, because this velocity code that we have here in the update method, it has been moved into the level. So this is where we actually move things right now. And we shouldn't have things just lying around that doesn't do anything. So I removed it. So as always, when we change something, even though we don't think it's not a problem, we're gonna test it and it checks out. A couple of episodes back, we moved something away from the sprites.js. We used to have a load background sprites here that we decouple into a background loader, what was called a sprite sheet loader. And I want to do the same to Mario here. I want to define this data here as JSON and parse the JSON and create sprite sheets. So I'm gonna open up the overworld JSON here. I'm gonna save this as mario.json. And we're going to remove some things here that doesn't apply. For example, the tile size and tile width is not applicable for Mario. And we can remove also the tiles. So we have left now a URL to tiles.png, which isn't right either actually, because the sprites here is using characters.gif. But we can use this to copy it in here. And then we're going to define all the information here as JSON instead of JavaScript. So where are we? Mario.json. I'm gonna paste this in as a reference. And what we need here is a set to define frames. And each one of these definitions, every time we run sprites.define, I'm gonna call that a frame. So I'm setting a little key here called frames, which is gonna be an array. And the frames come with a name. And this is gonna be, and the name of this frame is gonna be idle. Then I'm gonna call the data here for a frame. I'm gonna call that a rect. So that's the rectangle to use from the image. And I should just be able to copy the arguments from function into a JSON array here. And that's actually everything we have to do for now. Nice. So now we added a new key here to this JSON called frames. So we need to add support for frames in the load sprite sheet function here. So the first thing we're gonna do is make the tiles key optional. So I'm gonna wrap this in a if statement. Okay, now I'm not, that's messing up. And then I'm gonna add an optional frames key here too. So sheet spec.frames, which means if a frames key exists, we're gonna loop over it. So sheet spec.frames.forEach, and we call this frame spec here. And what the frame spec can do is define a tile, just like the tile spec can do here. It defines a tile. A frame spec can define just a regular free for all rectangles tiles, just like we do for Mario. So all I have to say here is sprites. It is sprites, right? Yes, .define, and we have the name, so frame spec.name. And then we need all the rectangle, and then we have the rectangle array here. And you can actually, when you have a data type like this, an array in JavaScript, you can spread the array as arguments in a function. So instead of having to write, basically, it would be frame spec.rect 0 and then frame dot rect 1, etc. We can actually just say frame spec dot rect and then prefix it with the spread operator here. So now this means that I should be able to use this load sprite sheet function for the Mario sprite sheet in the entities file here. So I'm gonna start by exporting load sprite sheet, export, and then we go to sprites. I should close some files here maybe. Okay, this I can close, and level I can close. So anyway, I go back to the entities and I'm gonna replace load Mario sprite with load sprite sheet. So we change that and we change that and we type loaders here instead, and then we name Mario here. And if I type Mario here, it means it's gonna resolve in the sprites folder for Mario.json. I'm gonna log this out here, the sprite sheet, and let's refresh the window and see what happens. And it worked. So I'm super happy about this. We have our idle tile here, which is a map, and it has the right size, which is great. This means that we have now deprecated the whole load Mario sprite and does the whole file. So I can just delete this whole sprites module. And we don't need to log this out, so I'm going to remove that for now. So now I'm going to add some more frames here to the JSON file. And the way this is going to work is that I'm going to use a little tool here that I created. And in this tool you can put in an image, and you can draw out a rectangle like this, and then you can quantize to the pixels and you can transpose it so it's at the right spot, and you can change it up a little bit to fix it. Actually, this UI here is not very good. If somebody wants to reuse this little project to fix it up, feel free to do so. It is open sourced on my GitHub account, and it's basically a little React project. But anyway, this is what I've done. I have found out all the points for these Mario tiles. So that's the work I have done. But for now, I'm going to just paste in this file here. Boom! There we go. So that means that I can now say run 1 here instead, and we should see a running Mario frame. Whoopsie daisy. Let me turn off these layers here, because we don't need the debug layers for now. So now we have Mario running around here, but he's pretty static still, and he's not really reacting to what we do. So we're gonna go in here, and I'm gonna create a little function that can route the sprite name. So basically it's gonna be a big router that looks at the Mario object and then decides what the frame we should play for this what do you call, for the state. So I'm gonna call this function route frame, and it's gonna take a Mario, and it's gonna return idle by default. So now I can run this function and put this output to the sprite draw method, and it's gonna take this, which is Mario. Okay, so that works so far. And now we're gonna add the first exception here. And what we can say is, in the go trait, we have a direction. And when this direction is not 0, we should run. So I'm gonna go in here again, and I'm gonna say if mario.go.direction is not 0, then we're gonna return run-1. So that's a little bit closer. Now he's ice skating, it looks like. But we can obviously we need to do better than that. So let's get at it. So I'm gonna specify which frames to use up here. So I'm saying const frames, and I create an array, and I put run-1, I put run-2, and I put run-3 in it. So I want to know which one of these frames I'm gonna take. And one way to do it is to figure out how far we have run, and then just transform that into an index. So I'm gonna go to the go trait here, and I'm gonna add a this.distance that I initialize to 0. Then, at the end of the update method, I'm gonna update the distance variable, or the distance property. I'm gonna add entity.velocity.x times delta time. So here we calculate the velocity he has times the time he has this velocity. So basically here we get the distance of running over time. So we go back here to the Mario entity, and I'm gonna log that out. Mario.go.distance, and let's see what that looks like. Here we go. So we have an ever increasing number. Or actually it goes down when we go backwards. We want this to always increase, so let's fix the down when it goes backwards. We can do that by us saying math.apps for entity.velocity.x. So now we should always count upwards. So we go, no matter what direction we go, we're counting upwards. But I also want to reset this number when we're not moving. So we can simply say if this.direction, then we count, else we define it to be 0. So now it should count upwards while we're running, and then go back to 0 when we stop. And every time I stop, you can see that it counts from 0 again. So I run here and I stop, it's 115. I continue running, and it goes back to start from 0 basically. And we have a number like this that's always increasing. We can use modulus on it to get these indexes. So basically, if we have the frame.length and use that frame.length to modulus value, we will never go beyond 3 here. So now see what happens here to the output. It is that it always stays below 3. So it's 0, basically goes 0 to 0. If it goes too fast now, so we can't, it doesn't go in order. So let's slow it down a little bit to see what happens. So I'm gonna slow it down by 1/10 there. And now you can see here that it slowly grows up to 0, 1, 2, then it goes to 8. This is a very tiny number. This is basically a 0 we have here. It's scientific notation that threw me off a little bit. But if we don't want it full, we don't want those decimals, so we can floor this value to get an integer. So now you can see here, when we walk with Mario, that we have a nice loop that is 0, 1, 2, 0, 1, 2, 0, 1, 2, and the same goes for going backwards, 0, 1, 2, 0, 1, 2. And this we can transform into an index from the frames array. So if we call this const frame index, and we console.log out frame index and frames frame index. So basically we say if it's 0, it's run 1, if it's 1, it's run 2, and we log out the frame index and the frame name here. So let's see how this works. Run 1, 2, 3, 1, run 2, 3, 1, 2, 3, 1, 2, 3. Okay, it looks great. So now we can call this the frame name. And we can return the frame name instead of a static run 1. So here we go. There we go. And Mario is running. Oh, I love this part. This is like when the characters come to life for the first time. That is lovely. But this is a little bit nasty to write all the time. So we're gonna normalize this into a helper function. So up here, I'm gonna write function, create animation, or create anim. And this function is gonna take a number of frames, and it's gonna take the frame length. And then it's gonna return a function that we call resolve frame. And it's gonna take a distance. And we should be able to basically copy these values into the returned function. And we normalize this down to so that this is not mario.go.distance. And this is not hard-coded 10, that's the frame length. And otherwise it looks right. And here in the end of the return function we return frame name. Now we can use this create anim function to create an animation function that takes a number and gives back a frame. So I'm gonna call this run anim, and it equals create anim of these frames, and it uses this value 10 here, which is basically the speed of playback per frame. And down here I can now simply say return run anim for mario.go.distance, and we can remove this. So basically now we created a very tiny nice API for creating animations from tile names that just takes one value. And the reason this is called distance here, it is because it is the distance in the animation timeline, if that makes sense. So in this case it is how far Mario run that is the distance, but this doesn't really reference distance in the sense of how far things have moved. It could be anything. It could also be time, the distance of time that have elapsed. So let's see if our simplification worked, and it did. So let's take this create animation function and put that in a little animation library. So we export it here from a new file, and I'm gonna save this as anim.js. So anim.js is here. So now we go back to entities, and we want to import create anim from anim.js. And we make sure it still works. That's great. We have one big thing missing here, and it's that Mario is always running to the right, which looks a little bit stupid. So to prevent moonwalking, we need to create flipped tiles. We have another option, and it would be to just define more tiles here for when running the other way. But I think it's better to let the computer do this. So for the case here when we basically just have mirror tiles, we don't want to do this job. So we can improve our little sprite sheet that we haven't touched for a while. And I want to here in the define method, I want to preemptively create mirrored tiles for everything. And there is a simple way to draw a mirrored canvas. I'm gonna first break out the context here. Const context equals, and we take this little part here. Because we're gonna use this context property to do some things there later. So I'm gonna clean that up a little bit. And then I'm gonna say context.scale are -1 and 1. And translate is going to be -width and 0. So if I do this job on the define tile, everything should be mirrored. So let's see. And it is. The whole thing has now been mirrored per tile. So this means that if we create 2 buffers for each define, we can create one mirrored and one non-mirrored. It turns out that I know a nifty trick for this, and it is to put all this in a loop and do it twice and just flip it once. So I'm gonna create 2 buffers. So I'm creating an array here, const buffers equals, and I'm gonna hard code true and false in an array that I immediately map over. And map does the exact same thing as for each, except that it creates a new array from the return value of the function you put into map. So here we define an arrow function that we give an argument that is flip. So what is going to happen here now is that we loop over false and true, and then we name false and true to flip here. That means that we can say that we only flip the image once here. And if we return the canvas here in the end, or sorry, it is the buffer, we will create a non-mirrored buffer for the false argument. Then when it runs again for the true argument, flip will be true, and we will run this code to mirror it. This means that here we will have two canvases in the constant buffers. If we save those two buffers in the tiles as sets, we now have two canvases on each name here, on each tileset name. And that means if we use index 0 when we get the buffer out in the draw function here, we will get the straight buffer. So here we're back and nothing is mirrored. And if we take number 1 here, everything is mirrored. That means if we add a little argument here to the draw function, or the draw method, that's called flip equals false. So it can say flip, then draw index 2, otherwise draw index 0. So what this means is that everything is as normal when we start, but if I go here to the Mario entity and I supply the flip argument to sprite.draw. So here I call what we just changed in here, and the fifth argument flip is empty and defaults to false. But I'm gonna say that the last argument is the direction of Mario. Mario.go.direction, and if it's more than 0, it is true. So it needs to be less than 0. So basically, if we're running to the left, then flip the image. If we're running to the right, don't flip the image. Oh, almost. I got it inverted actually. So it should be like this. If we're running to the right, I don't know. I thought it could be right, but the proof is in the pudding. Actually, I don't know what's going on now. Didn't I get this right? Okay, let's try this. .go.direction then. Okay, this is still wrong. And should it be like this? This.go. If it doesn't work now, I'm gonna have to debug. Oh. Okay. Yeah, now it works. So I run to the right and he faces right. I run to the left and you face left. And what I can see now though is when I run to the right is fine, when I run to the left is fine, but when I release the button, he faces to the right. It's because direction is going to be 0 when we release the button. So that means that we're basically always going to face right by default. So we're going to add a little bit of memory in the go trait. So I'm going to call this bit of memory heading, and I'm gonna default it to 1. So we default to being heading east or right. Then, if direction is set, I'm gonna set this heading to direction. So it means that if direction here is 1 or -1, we're gonna set heading to 1 or -1. Otherwise, we will not set it. So if I do like this, console.log this.heading, I'm gonna prefix this here with heading. You can see that it's 1 when I go left, it's -1 when I go left. Sorry, it's 1 when I go right, it's -1 when I go left, and when I stop, it isn't updated. It's only updated when we give it stimuli. That means that we now can use this heading value to pick direction. So this.go.heading we can use, and now Mario remembers what way he was facing. Okay, so this is basic animation for a character. And now we want to look at how we can animate a block here, a tile. For example, these chance blocks. So not actually, for example, we're gonna animate one of these chance blocks. So the first thing I want to do is go back to code. I'm gonna close down some of these files. And then I'm gonna open the level JSON here. And I'm first gonna make a little convenience change. I'm gonna put a chance block in the beginning of the level so we have something to work with. So I basically put it here, and that way I don't have to scroll over or set up anything else to see what my changes do. And now I'm gonna open up the overworld sprite set. And I want to... what do I want to do here? Yeah, I want to add more tiles here. If we go in here to our little tool that I made, and we're gonna open up the tile set here, we can see that they are beside each other. So it means that these are just on index 24, 25 and 26, I think. So I'm gonna make a copy of this one. Almost. And I'm gonna do a similar thing for what I did to the run sprites. I'm gonna prefix them with -1, -2 and -3. And I'm gonna just update this index here to 25 and 26. Notice here that I save this old chance block so that we don't break the code while we're changing it. It's better to just add some features and then remove the old feature once we're done with it and don't need it. And what we also want to define in this overworld is to define that these constitutes an animation. So I'm gonna add a new key here that I call animations. And it's gonna be an array, and one animation in it is gonna have the name chance. So basically here we're gonna bake into these three to define an animation. And our animations have a frame length, right? It's gonna go to anim.js and see, yeah, it takes frames, it takes a frame length. So the frame length for this, I am not sure, but I think we're gonna go for 1 second in this case. Just remember here that the frame length here, this is unitless. It's agnostic to what unit is. It just defines here are the frames, here how long you think a frame is based on anything, and here is the distance where you want to resolve a specific frame. So in this case, it's gonna be seconds, but it's also, at this point in time, we don't specify what the unit is. We just say that it is one of whatever we give the resolver. And then finally the frames. And here we should just be able to say chance-1, chance-2, and chance-3. Or 3, I mean. So let's make sure we didn't break the JSON by refreshing. Yeah. There we go. So if you have noticed this, by the way, that we have these slowdowns, it is because we don't stop the timer ever, even when we're in the background. We are gonna fix that later, but for now I'm gonna make a little hack in the timer that just says that if accumulated time is more than 1, set accumulated time to 1. So that means we never go beyond 1 second in the simulation phase. So even if we wait for an hour here, we see that the last time was an hour ago, we're just gonna flatten accumulated time to 1 second. So that's a nice little fix if we want to do that and get rid of that problem. So before we continue here, I'm gonna remove this noisy console output here. Let's go back to the Go trait and remove this. So there we go. So where were we? Yes, we defined animations here in the chance in the overworld.json. So now we want to open up the loaders. I want to scroll down to our sprite sheet loader. And we want to create a class here for parsing animations. They're going to be similar to this. I'm going to copy and paste this in here. And then instead of looping over the frames, we're going to loop over the animations. We're going to get an anim spec out here, which is just each item. And what we want to do with it is create an animation. So we say const animation, and we're going to say create anim spec.frames and anim spec.framelength. So what we did here is of course run this function that we haven't imported. So let's go up and import it. We import create anim from anim.js. And what we're going to do with this animation, we're going to add it to the sprite sheet. But the sprite sheet doesn't know what an animation is, so we need to update it a little bit. So we're going to go in here, open up the sprite sheet class, and we're going to give it some love. Up here, I'm going to add a function that I call define anim. And it's going to take a name, and it's going to take an animation. It's going to add this to animation map. So this.animations.set name animation. And we have to define this here in the top. And it's going to be the exact same thing as the tiles map. So basically when we run define anim, we put it into this map on the name of the animation. And this name I intend to be the same as the name we defined here. So the first thing we iterate over here is going to be the chance animation. So because we added this define anim up here, that means we can run this method on the sprite sheet here in the loader. So we say sprites.define anim, and it's anim spec.name, and we send in the animation that we created. So this one. So let's log this out. Whoops, and we can see here that the animations is 0 for this one, so that's probably Mario. And here we have a map containing a chance that points to a function that's called resolve frame. So that's very nice. Now we need a way to draw this animation too from the sprite sheet. So down here by draw tile, I'm gonna add a function called draw anim, and it's gonna take the animation name, and then we're gonna take the context, x and y, and the distance. So it's basically draw tile, but as but with distance here. And first we're gonna resolve the animation, and it's gonna be in this.animations.get name, and it's gonna call this.draw tile with animation at distance context x and y. So that means that we now should be able to draw the animation we had using supplying its name and the time here, or whatever we pick. So now I'm going to open up the background layer here, and here I would like to draw by an animation sometimes. So I'm going to check here if tile.name equals chance, then we're going to run sprites.draw anim, and we're going to draw it at distance 0, else we're going to do the regular thing. Actually I'm going to put that at index 1 to see what happens here. So now it's dark. So what can we do to move forward in time in order to make this flash? So it turns out that we can use the level time. We don't have this yet, but it's super easy to add. We go into the level, and then under gravity I'm gonna give this total time. I'm gonna define a property called total time here. And every time we update with delta time. I'm going to accumulate total time. I'm gonna add delta time to it. So this basically lets us know how long the level has progressed from 0. So we can use this total time property to send out to the animation. So we go back to layers and we send in level.total time here. And now it should start blinking. And it did not. And oh, it does something. Oh, you know what this is? This is our cache layer. Up here, we don't redraw the background if the index haven't changed enough. So let's just remove this for now. And we take a lesson from this that early optimization is bad. So now let's see what happens. There we go. Okay, we have it flashing here. It looks pretty good, I think. But it should definitely go faster. So I'm going into our little overworld here and I say that frame length is 0.1. Oops, 0.1. See what this does. Looks a little bit too fast, I think. 0.15. Yeah, I like this better. But there is something that is a little bit off. I'm gonna bring in this as a reference here. Let's start this. So it looks like it flashes dark and then is lit for a little while. And this is just going light, darker, darker, light, darker, darker. So we're gonna add a little bit of ordering here. So basically I want to play the first frame twice. And then I want to play it in the end. No, I want to play frame 2 in the end. So that we go light, light, darker, darkest, lighter, and then we start from beginning again. So let's see how it is now. I think that's pretty close. Maybe we can go a little bit faster, but this is probably unnecessary optimizing. We should just measure it if we want to have it exact. Okay, I'm gonna be happy with this. So I'm pausing this and put it on the back burner. So now we basically have most things we need to have animation right. You see it's animating over here. And the level is long, and all of these are animating wherever we are. But the thing we did here to know when we should draw them is not that nice. You can see here that we just hard-coded that we should not do that. But what we can do is, at least for now, say sprites.animations.has, and if a tile name has been defined, or sorry, if an animation has been defined by that tile name, we can draw the animation. So we will prefer a defined animation before a defined tile. And now it works. So that is the episode on how to create animation.